Hello, everyone. Welcome. My name is Oksana, and welcome to Continuous Testing Meetup. So moving forward, at first, I want to say a big thank you to our sponsors, SoulSlip, to Amusement and Trendy, to allow us to provide this meetup, to pay meetup fees, and to help to find the speakers and organize the whole process of meetup. So, and also big thank you to Aurelian. So then, if you passed our last meetup, so with Christian Giaconi, how to log a bug, you can find a video recording there already on our continuous testing meetup.com. Just go there and find the videos from the last meetup. So what else? Next week, it's already next week, you can join Europe's greatest agile testing conference on site in Potsdam and also virtually from the whole world from Monday to Thursday. If you have opportunity and if you want to join the conference, you can also have a small discount. So use discount codes for attend virtually. You have a €50 discount, or you can also have a 15% off if you want to attend on site. So probably see you there at Agile Testing Days in Potsdam. So then moving forward, so today we have James Martinson join us from Portland, United States with his topic, Test in the Cloud for Free. So thank you, James, to join us. So the stage is yours. For all participants, please don't forget to mute yourself. And if you have any question, just put it in the chat here or else in the Slack channel. Aurelian will post right now the link to the Slack channel. After the topic, you will have the opportunity to unmute yourself and ask the question. So, James, the stage is yours.
Thank you, Oksana, and really happy to be here. Thanks for the opportunity to come and speak. Thanks, Aurelian, for helping me to get everything organized. And thank you, everybody who's in attendance, for attending my talk on running UI tests in the cloud for free. What we'll be exploring is taking the Docker Selenium container images and running them on serverless container platforms such as Google Cloud Run, Heroku, and other options that are out there currently. So the challenge that I faced when I first started to explore Selenium grids and how to set them up and where to set them up, I wanted to be able to set them up in the cloud. And the only documentation that I really found out there was how to set it up on a virtual machine, like let's say a Google Compute Engine or an Amazon EC2 instance. There is also Kubernetes as another option. And with because at the time in our company, we weren't really ready to automate all of our tests. We were still kind of looking into exploring this. So I didn't want to set something up that was just going to sit there and burn away money. And virtual machines, for the most part, are going to run 24/7. Even if you're not using it, even if it's just sitting there, it's still incurring some form of cost. Kubernetes, from what I know about Kubernetes, it can scale up and scale down, but my understanding is it doesn't really scale down to zero. And again, I thought to myself, I don't necessarily want to have something that's going to, eat away at money or sit there and eat away at any free plan that I have. And I knew that Google Cloud Run and Heroku were both capable of running containers. And I thought to myself, why isn't there any documentation on how to run these on those platforms? So I started to dig into it a little bit, and but before I get into the experience getting it set up on these platforms, I just want to point out that the running it for free is, you've really got a couple options. One is that they really only run on like, you can really only use lightweight web browsers with platforms like Heroku, Koyeb, and that's because the Chromium-based browsers tend to use a lot of RAM. So Chromium browsers like Chrome, Yandex, Brave, Microsoft Edge. I found that if I tried to use any less than 2 gigabytes of RAM, I'd have trouble running those browsers. Firefox as well tended to need a lot of RAM, but when it comes to web browsers, we've got 3 major types of browser engines that are out there. There's all the Chromium browsers run on Blink, Firefox runs on Gecko, and then browsers like Safari, Apple Safari, runs on WebKit. And a lot of the quirks that you see in browsers really, it really depends mainly on the browser engine. So if I come across some quirky behavior that's happening in Chrome, I'm most likely also going to see that in Edge and Yandex and other Chromium browsers as well. Same thing with WebKit browsers. So with Safari, the challenge is it's on a Mac. It doesn't run on Linux, so we can't really run those in containers, but we can run Epiphany or Mini Browser in Docker containers. So I did have a lot of success running Mini Browser, which is basically a very scaled down WebKit GTK browser. And I'm able to run it on Heroku for the past 3 or 4 months on just 256 megabytes of RAM. So that's really, really low power. The other success that I had was running on Oracle's ARM virtual machines. Now, a minute ago, I was just saying how virtual machines tend to eat away at your cost. Well, Oracle has a really nice free plan, and I'll explain a little bit more about that later on. So a little bit about who I am. I live in Chennai, India. I've been there for 8 years, been with the company for 15, and I've worked on a variety of different things since I've been here. Anything from lead capture systems to get a lead from our website into a salesperson as quick as possible, to helping bring elements of Scrum into the organization, and helping our team move remote. And most recently, I had the opportunity to work with our QA teams to help with code quality and test quality. And my background's a programmer, but I never really worked with automation technologies until just recently. And I feel like it's really opened a lot of doors for me to get into open source, as well as to find other opportunities to help our organization get more transparency. So,
James, sorry, can I ask a question?
Yeah, sure.
I'm not sure if you're going to share the slides or not, because we
are you not seeing slides?
Yeah, exactly so.
Oh, let me make sure I'm sharing my screen.
I had it up too. I wasn't sure if you were to the presentation.
Yeah, sorry about that. Let's go here. Okay, sharing screen. Okay, how about now?
Perfect.
Good.
Basically, I don't think anybody really missed much. We've got the title slide here, and then the slide on what we'll be exploring with this nice picture here of this euro coin on top of a bunch of rocks, and then the who am I page. So page 2 here. So I am a recent committer on the Docker Selenium project, and I will take a moment to talk about that project because I think understanding it will help with the rest of the talk. So for those who aren't aware, Docker Selenium is basically a collection of container images that contain a Selenium server, a web browser, a web driver, and a no VNC client. And what this lets you do basically is with one simple command, you can set up a Selenium server and immediately run tests, and also watch those tests in real time in your own browser, but you're able to see the remote desktop virtually. So I also am the maintainer of Selenium's first community-based repository, and that's Docker Selenium ARM. And basically what Docker Selenium ARM is, it's Docker Selenium for ARM computers. So if you're running on a Mac M1 or a Mac M2 or a Raspberry Pi, we did find that there were a lot of people with those computers who with those architectures who weren't able to use Docker Selenium. So we got this fork up and running and have been maintaining it for the past year. So so on to how do we run tests for free, or in the case of Cloud Run for a really low cost? Well, as I was mentioned earlier, what really drew me to Cloud Run was that it could, unlike a virtual machine, it's a platform that basically starts up on demand and shuts down automatically. With virtual machines, I probably could have gone into the interface, started it up manually, and when I was done, shut it down, but that's kind of a headache. What I really liked about Cloud Run is if I wasn't using it for 3 weeks, there was no cost. There's no, nothing that I had to worry about in terms of having a bill pop up later for something that I had forgotten about. With Cloud Run, you basically pay for what you use. The key is just make sure that it scales down to 0. There was a pricing calculator that I had that I used. I put some numbers into it, and it said basically that my cost would be 0. But in practice, I found that there were some hidden costs on Cloud Run. Most of the costs went to network egress. So I believe that was just the cost of the traffic coming from the container's web browser out to the public internet. But it wasn't much. It was basically like the cost of a cup of coffee. So it wasn't a lot. So the problem that I ran into when I tried to deploy one of the Docker Selenium containers to Google Cloud Run is, well, I was able to get it to deploy. But as I mentioned earlier, there's 3 different services that are running on these containers. There's a Selenium server on port 4444, a VNC server that listens on port 5900, and a no VNC server that listens on port 7900. Cloud Run, and I found that most of these serverless container platforms had this problem. You can only expose one public port. So, and really they're only designed to run one service, but in some cases, it's good to bend the rules. And when it came to Docker Selenium, having multiple services on there made something that was really useful to the community. The problem with Cloud Run, I could open port 4444 and I could run the test, but I couldn't see anything. I could deploy another container, open port 7900. I could see the desktop. I could interact with it. I could do some manual testing in a browser that I might not otherwise install on the Mac, but I couldn't run any automated tests because port 4444 was closed. So before I move on to how I solved that problem, I just want to paint a picture of what this looks like, just to help anybody that's maybe not familiar with Selenium standalone Chrome kind of get that picture. So over here on the left side, this is our local workstation. In the middle, we've got the public internet. And on the right side, we've got a Selenium standalone Chrome Docker container. And on the local workstation, we've got our local test application. This could be something like WebDriver IO or Selenium or Nightwatch.js or some type of testing framework that can work with WebDrivers and can work with Selenium servers. Down here, we've got our local web browser. This could be whatever your favorite daily driver is. It could be Chrome, it could be Safari, Firefox, Microsoft Edge, whatever you use to, on your local computer. Well, you can see with Docker Selenium, with Selenium standalone Chrome, we've got 2 ports that are open. And the test application's connecting to one port, the web browser is connecting to no VNC through the other. All the test commands are sent to the Selenium server, relayed through to Chromium, and then relayed over to the browser that's running in the container. And of course, all the responses to those actions are going to come back through to Chrome driver, onto Selenium, and then back to the test application. So for instance, if the test command is to open the browser and navigate to example.com, we'll then be able to assert whether or not that actually happened, through the response. So there were a couple different things that I tried before I found the solution to this problem. And the first thing that I had tried was to use SSH tunneling to tunnel through an open port through SSH and open up other ports from the inside. That did work locally with no problem at all. I was able to expose a single port through Docker, connect through SSH, open up, other ports through the tunnels and run tests. But when I deployed it to Cloud Run, I found that I wasn't able to connect, and I believe that was because of the load balancer that Google has sitting in front of the containers. So the second thing that I tried, I came across this tool that's about a decade old. It's called SSLH, and what it is it's a multiplexer. And what a multiplexer does is it's able to listen on a single port and for different types of traffic. So SSLH could listen to both SSH traffic as well as HTTPS traffic. And depending on that traffic, SSLH could then forward it on to a different upstream server, either the web server if it's HTTPS traffic, or the SSH server if it's SSH traffic. Again, that didn't work either. And I think, again, the load balancer was to blame for that. So then I thought to myself, well, I can only open one port, and it has to be HTTPS traffic. How can I handle that? How can I have two services listening on a single port? So Nginx is an open source web server. It's also a reverse proxy, a load balancer. And in this case, I decided I was going to use it as a traffic coordinator. So basically, Nginx inspects the request path. And if it's a request path that would normally, include traffic that would get sent to Selenium, then Nginx would send it to Selenium. But if it was traffic that would go to the NoVNC server, then Nginx would send it to NoVNC. So here's what this looks like. So this is the Selenium standalone Chrome container here on the right side. But this time, the Selenium server and the NoVNC server are now private services. They're not exposed to the public internet. Instead, the Nginx server is exposed to the public internet through port 8080. Privately, publicly, it's going to be port 443. And you can see now that both the test application as well as the browser are connecting through the same application, through the same ports. Just Nginx is able to analyze the request path and forward it onto the correct upstream server. When I deployed this to Cloud Run, it did work. I was able to run tests. Quite frankly, I was a little surprised that it worked. This just kind of started out as an exercise, just because I really wanted to see why no one had, or why I couldn't find any documentation on this. So I was really surprised that it worked, and I was able to run tests without any problems. I realized that this thing was sitting out in the public internet exposed, and I didn't like that idea either, because there's a lot of information out there that you can find on publicly exposed Selenium servers that have been hacked or that have been used as an attack service to get into a company's network, and I didn't want to be that person. So I did put some basic authentication in place, nothing fancy. I knew I didn't need a fully fledged authentication system, but I did want something so that the container would know it's me that's making the request. And basically, it's just a token in an auth header. And well, let me just go ahead and show you a demo of what this looks like. So I'll pull up Visual Studio Code. Okay, so what we're looking at here is one of the configuration files. Let me pull up the one for Chrome. So if anybody who's familiar with WebDriver IO has probably seen the wdio.conf.js file before. And this is an extension of one of those configuration files, basically an override. And to make this work, what I had to do is I had to change the port from 4444 to 443. Because I'm connecting to the public internet, it needs to be HTTPS for the protocol instead of the default HTTP. The host name, I use an environment variable to be able to substitute, Chrome versus Firefox versus Edge or the mini browser. So that gets sent through as an environment variable. And what I really like about WebDriver IO is they have a hook in place where you can send headers with the request to the Selenium server. And I use that to basically plug in that access token. There's also a service that I put in place because one of the problems that I did run into is because the Cloud Run servers are usually sleeping, they needed some time to warm up. Basically, it takes maybe about 10 to 15 seconds for Selenium to spin up and for the NoVNC server to spin up. So what this service would do, this Cloud Container service, is it would monitor the response code on pings to the Cloud Run container, and as soon as it got back at 200, it would then allow WebDriver IO to continue and start running tests. So basically, if I were running, WebDriver locally, WebDriver IO locally, I would use this. Because I don't want to use the default configuration, I'm going to use the Cloud Container configuration. And if I were to try to run this with without any authentication, it's going to basically tell me that somewhere in here we should see, move my video out of the way. Okay, there's no URL that's passed in, so basically the host is undefined. So we'll have to add that in. So Cloud Container app URL, and that is going to be this URL. Except I'll get rid of the trailing slash and the HTTPS. We won't need that. So if I try to run this now, the server's URL is injected. We can see right here, it's logging the URL, but we're getting back 401s. And this is that authentication that I was telling you about. If I want to get past the Nginx proxy, I've got to substitute the token. So we'll put that right here, Cloud Container Access Token. And I recommend using something fairly strong. I just come up with like a random GUID or something that I know won't be easily guessed. But for the purposes of the meetup here, I made it something really simple. So now everybody knows the token. I'll have to delete everything after the talk is over with. Okay, so we'll hit enter now and we should see some success. So I'm going to come over, while that's warming up, I'm going to come over to the browser and I'll log in through the NoVNC container or the NoVNC service. And here's our desktop. And I just want to point out that the URL, you can see this is a remote URL. It's not on my local computer. Now you can see the tests are starting to run as well. So this is, these tests are written against the internet, which is basically a test website put up by, I believe it's Sauce Labs, for QA engineers and developers to basically practice writing tests. So I have a series of tests written against this website, mostly just to experiment with this platform. And they usually take about 2 minutes to run. So in the browser, okay, so authentication in the browser. You saw authentication in WebDriver IO, but the other question you might be wondering is, how is the browser able to access this server? So I've got a couple other containers open over here, and you can see this 401 authorization required. So to pass in the token to Cloud Run, I'm using a Chrome extension called mod headers. And what mod headers basically allows you to do is you can modify the outgoing requests. And what I do here is I just add in the secret token, CTM meetup secret token, and I'm able to whitelist all the different URLs that I want this token to be sent with. So this was from when I was playing around with it locally. You can see I'm running it on Koyeb, which is another platform similar to Heroku. This is all Cloud Run URLs right here, and this is an Oracle server. So once I reload the extension, you can now see this 502 bad gateway. And this is basically just Nginx saying, I'm up and running, but the services that I'm supposed to send the traffic to in the background aren't running yet. The Selenium server, the no VNC server. So it's just responding with a bad gateway. So that's a detail that I'd like to eventually figure out how to clean up. But if I refresh, you can see the no VNC client, and we can again log in to the Firefox container. So over here in Chrome, we'll just see how those tests are doing. Oops, wrong password. I think everything might be completed. Yes, so there was 11 tests. They all passed. It took 2 minutes, 25 seconds. And yeah, so I could do the same thing on Firefox, Edge, the mini browser if I wanted to do that as well. So there are a couple different providers that I did experiment with. Cloud Run was the one that I probably played around with the most, and mainly because I could run Chrome, Firefox, Edge, all the browsers. With Heroku, if I tried to run the anything other than mini browser, it just died. But with mini browser, I was able to run tests in a GitHub action workflow every day for about 10 minutes with no problems for about 4 months. But the bad news with Heroku is their free plan is ending on November 28th. So that's something that I think is a little depressing for those of us that like to play around with that platform. But there are alternatives out there. There's a platform called Koyeb, and they have a free plan that supports up to 512 megabits of RAM. And I was able to get mini browser running in Koyeb and running tests on it. Their free plan also, it's possible to run up to 2 gigabytes according to their founder. But what you have to make sure you do in that case is make sure the scaling is set to 0. Otherwise, you would incur about $10 a month of usage. But if you can get it to scale to 0 and only launch when you need it, it's very possible to, I believe it may be possible to run Chrome on Koyeb for without any cost at all. So I've yet to try that because I just got the news about Heroku a couple weeks ago. So there's also I also wanted to mention Oracle's platform, and I really think Oracle is something to look into if you are okay with some Linux system administration. Now, Oracle has a free plan where you can take basically 24 gigabytes of memory and 4 virtual CPUs, and you can mix and match them any way you want to create up to 4 different virtual machines. And that's really awesome. I've never seen a free plan with this amount of virtual machine space. So for instance, you could set up 4 virtual machines with 6 gigabytes each with a single processor. You could set up two 12 gigabyte machines with 2 CPUs each, or you could set up a massive single 24 gigabyte 4 virtual CPU ARM server totally for free and no charges. I've been running one of these since January, and Oracle's yet to send me any bill. They do require a credit card, and basically that's just to validate that you're not a bot or a spammer or somebody that's going to try to abuse the system. But they do promise that they won't bill you unless you specifically go in and enable their billing plan. And that to me was really key because some of the platforms, once they get your credit card, you don't know what's going to happen. You may wake up and find a bill, and there's some horror stories out there on that. Since it is ARM, so basically Oracle's virtual machines are ARM and peer machines. That does mean that you can't use Docker Selenium, but you can use Docker Selenium ARM, and that will work. I've tried that out. It works great. But but it isn't secure by default. And this is where I say the Linux experience, the Linux system administration experience really comes into play. In order to be secure, you have to have a domain name to point to the server, an SSL certificate, and you have to be familiar with configuring firewall rules, because it's really easy to have something open that you don't want to have open. And on these servers, when I look at the logs, there's just an army of hackers that are just trying to get in. So services like fail to ban, making sure that only the ports that you're using are open, and going into the cloud dashboard, and also making sure that you have security rules in place. Those are all really important if you do go this route. So that's just my one warning there. But before I end, I do want to just kind of show you what the billing looks like. Also, I do have another demo to show you as well. And so the ending slide kind of came a little too early here. So I do have a demo in GitHub Actions. Just going to move this out of the way real quick. Okay, here it is right here. Okay, so I set up a workflow in GitHub Actions. The window's in the way again. Let me move this. Workflow file. So anybody here ever wish that you could run tests on GitHub Actions and also watch them at the same time? That's something that I always wanted to do. Whenever we were running on GitHub Actions, something would inevitably go wrong because the platform's different than our local machine. We're either using Windows or we're using Mac. And the moment we try to deploy something to Linux, all kinds of things go haywire. Well, and we couldn't see anything. Well, I'll show you this demo, and it's pretty cool. So this workflow uses what's called workflow dispatch, which basically means you can run it manually. And we're also using the matrix strategy. So just a little background on matrix. What that means is I can set an array of 3 different Cloud Run URLs. I have one for Chrome, one for Edge, one for Firefox. And then what I can do in the jobs that are running is I'm substituting this variable in the Cloud Container App URL. The token is stored as a secret in GitHub Actions secrets. So GitHub Actions is able to connect to the Cloud Run containers in a secure manner. And then right down here, you've got the WebDriver.io startup command. So I'm going to go ahead and just run this. I'll go Actions, Cloud Run tests, and run workflow. I'm going to make sure that these are all warmed up, because I recently deployed the newest containers. They're having some trouble with the warm up process. So I'll reload the extension. All right, and we'll come back to GitHub Actions. The tests are now running. You can see here there's now 3 jobs running on 3 different Ubuntu runners, Chrome, Edge, and Firefox. Let's check out Firefox this time. So tests have started. So I'm going to go over to Firefox and we'll go ahead and connect. So right now we have tests that have been initiated from GitHub Actions. WebDriver.io is running in the GitHub Actions Ubuntu runner. The tests are running in a cloud container on Cloud Run. And because we have the open port, because we have the I think it's called XVFB, it's a virtual frame buffer that basically lets us have this GUI. Because we have all that, we're able to see the tests running at the same time. And I thought that was one of the coolest aspects of this. Also, I'm able to scale these tests without necessarily having a Selenium grid. That was one thing I had wondered about, was what do I do if I want this to scale? And the answer is I can just use GitHub Actions. So if I set up multiple deployments of the Chrome containers and the Firefox containers and Edge and so forth, I can just add those in as additional variables in the matrix configuration, and GitHub Actions will just spin up more jobs. So also, it is possible to run multiple tests on the same Firefox container or Chrome container. There's a property called, I don't remember the exact property, but it's like a parallelization property. You can basically tell Selenium that I want to be able to run more than one session on this container. So that's a possibility as well. So that's that demo of GitHub Actions running the tests. Looks like Chrome's already finished and everything went fine, no problems there. As far as the billing goes on Cloud Run, I did get some charges. So let me move this out of the way again. I don't know if you all see the window in front of my browser, but for me, it's getting in the way. So let's move that up. Okay, so let's go to overview. These costs are basically the result of running the GitHub Actions, the tests in GitHub Actions on a schedule. So once a day for about 10 minutes, the tests will run on the various browsers, and you can see the cost. I don't know if anybody's familiar with rupees. I'll just show the conversion real quick, USD to INR. 81 rupees is basically a US dollar, and for those who want to see it in euros, 84 rupees per euro. So we're not talking much money here. So and what I really liked about that is to get in the door of most testing platforms, you're looking at $25, $30, $35 a month to start, and that's just to have an account. And with this, I feel like I had access to the cloud right away for virtually nothing. And on Heroku, up until November 28th, it was going to be free. But after that, we've got the other platforms like Koyeb. Fly.io looks promising. They also run containers. There's another platform called Northflank that looks pretty promising as well. They also have the ability to run containers. But again, their free plans might be the limiting factor. They only support, I believe, up to 512 megabytes. So to try to get a Chrome browser running on there is going to be pretty tough. The setup for these, so I'll go back to the service section here. The way to create the service, you click Create Service, and this user interface expects a fully qualified URL to a container image, but unfortunately it can't connect to public registries like docker.io or something like that. So you do have to push the image up to Google's artifact registry. And that looks something like, I already have them pushed up here. So once they're pushed, you just come into the artifact registry and pick the container you want to deploy, container image you want to deploy. Let's say we wanted Epiphany or mini browser. We would click this option here. I'll just expand this out. So there's one deployment that I made a couple days ago here. So I'll go ahead and click that. Service name, I would recommend just kind of keeping it the same as the container just to avoid confusion. Region, I honestly think I would have avoided any of the egress charges if I had stuck to US Central, but I did all my testing from a Mumbai server. And I was reading in the Cloud Run pricing guide that there's no egress charges in North America, but there is in other parts of the world. So that might explain the charges. Now the key to this, so one thing that I want to explain about services like Cloud Run is really they're not really intended to do what we're doing. We're kind of, I don't say we're abusing the system, but we're just kind of finding a creative way to use it. Really, Cloud Run is intended when you have a stateless web application that you want to deploy and you want to be able to scale it up to a certain number of instances. So let's say I have a Node.js app and I have some users that are going to connect to that service. If there's a database on the back end, and no data or state in the web application, then it doesn't matter which one of those instances my user connects to. They can make one request to container number 1 and a later request to container number 100, and it's not going to make a difference because the data is all kept in the database or it's kept in the front end in their browser. But in our case, we're dealing with stateful containers. Selenium standalone Chrome has state. So when WebDriver AO or Selenium or whatever tool you're using sends a command to the container, like let's say open a browser and go to the login page, there's now state in that container. So if we have 100 of these things, that's not going to work. When our request hits an instance, it has to be the same instance every time. So the really important thing to do here is make sure that you limit the number of instances to 1. Otherwise, you'll get a lot of flakiness and things won't quite work how you're expecting. The other important factor is to make sure that the scaling is set to 0. So number of instances has to be 0. This is so the containers will spin down once you're not using them. I set the ingress rule to allow all traffic. You do have a couple options for authentication. Google does have this IAM authentication where you can basically use a Google identity token instead of the Nginx authentication. But I went with the Nginx token because I didn't have that option with Heroku or Koyeb or some of the other platforms that I was utilizing. So to simplify things, I select allow unauthenticated invocations, and I let the Nginx server deal with all the auth stuff. So once this is in place, you go ahead and click create, and it will contain. I think that's about wrap everything up. If you do want to learn more about this, I do have the code that I had to use to make this work. There's the Cloud Container Service to warm up the Cloud Run containers. There's the demo WebDriver AO application with all the tests that I use to run against Cloud Run. The Docker files, if you want to take a look at what the Docker files look like, I'll show you a Docker file, the Docker file for the Chrome, Firefox, and Edge browser. Basically, what it does is it inherits from the upstream Docker Selenium containers. So this might be, let's say, from Selenium standalone Chrome. It adds in the Nginx server. And then what it does is at runtime, it handles the environment variables. So the access token, the secrets, none of that stuff is stored in the image, which is probably not a good idea to do. You want to make sure that's separate. So regardless of where this is deployed, whether it's Cloud Run or Heroku or Koyeb, as long as you have environment variables at your disposal, you can inject in this information at runtime. So that's the Docker file. And there's other files to support that, like the a supervisor file to handle starting up and managing Nginx, a template for the proxy. So basically, the port gets injected at runtime, depending on how it's configured in Cloud Run or Heroku or whatever the platform is. The authorization token gets plugged in right here. And you can see if it's not equal, it returns a 401. Otherwise, depending on which request path it is. So for instance, WD Hub, anybody who's ever worked extensively with Selenium, you've probably seen this come up in your logs, WD Hub. All that traffic gets forwarded to Selenium. Any session post or get or delete request, any request to see the status of the server, any request to see the Selenium console, all that stuff gets forwarded to the Selenium server. And all the other traffic we assume is no VNC. So we forward that over to the no VNC service. I also have a repository that has extensive documentation on setting this up. I did it as a workshop in my office. So if anybody wants to dig in further, you can check that out. And there's also a very lightweight proxy server that you can use as like a front-end proxy if your testing platform doesn't let you have the ability to override the headers. So for instance, one of the platforms I was looking at, there is no way to set the authorization token in the header. So the Selenium proxy sits in front of the test app, and its job is to inject that token when the request leaves the workstation. So so yeah, thank you everybody for your time. I hope this has been helpful. I hope it's useful. Sometimes I think that this has been an exercise in just learning more about these technologies. But if it is something that you do find interesting or want to learn more about, please feel free to reach out. You can find me on GitHub, Twitter, or by email as well at jmort253@gmail.com. So thank you again. I think it's Q&A time.
So thank you, James. So then let's start with the questions. Aurelian, I think you had the first question.
Yeah, I'm very, it's a super nice job. I mean, I knew a bit of the things you mentioned, but not all of them. So my question is very simple. How much time did you take to learn all those stuff?
A lot of time. It took probably about like 6 to 8 months of just toying with this stuff on the weekends and at night. And just I really like toying with things like this. You know, I like to experiment and find creative ways to make things work. So so for me, it kind of turned into a little bit of a passion project.
Mm-hmm.
But it was a lot of work. Looking at the Docker file, it's pretty simple, but that's like 8 months of work to get that to that point. So
Okay. Yeah, I was suspecting that you had a lot of passion to experiment, to learn all those things. Thanks.
yeah, thank you.
So any other question, just unmute yourself and ask.
Do you work on open source projects?
As far as open source goes, I am a committer on Docker Selenium. And I got that opportunity just because of the work that I had done with Docker Selenium ARM. I'll just pull that project up real quick here. Docker Selenium ARM. This actually kind of came out. I think the main reason I started to work on Selenium ARM was because of this project. In order to experiment with this stuff, I needed to be able to run it on the Mac M1, and Docker Selenium wouldn't run on the Mac M1. And at the time, there was a guy named Samuel. I can't remember his last name. I'm sorry, I can't remember his last name, but he had built Docker Selenium to run on the ARM platform. And there was a whole big issue in the Docker Selenium repository on this. And he had got it to build, but the containers were out of date by the time I had come around. They were probably 7 or 8 months old. And the Docker Selenium team had recently added the NoVNC client to the images. Before NoVNC, the only way you could connect was through a VNC client. And in order for me to make this work, I knew I would need to be able to work with HTTPS to try to get a VNC protocol to go through Cloud Run. That just sounded impossible. So in order to get NoVNC on the Selenium ARM containers, I basically had to figure out how to get them up to date. And once I got them up to date, I just kept, you know, once a week, I would just come in here and do a sync with upstream, and you know, just let people know in the group that the images had been updated. And then people asked, well, can we get them published somewhere? And I spent some time in Circle CI to figure out how to build and test these automatically and get them deployed to Docker Hub. And now it's to the point where it's almost completely automated. Whenever we do an update in Docker Selenium, I just come in here and I sync it, I make a commit, and all the building and deploying just happens automatically. So I do have other like open source things I work on, but they're pretty dead, I guess. They don't really have a lot of interest, and part of that just might be my lack of marketing them. But by far, these two are the ones that I find the most interesting, just because I think people find them really useful.
Yeah, nice job.
Yeah, thank you. Any other questions? Anybody have any other questions?
So if not, so then let's start with a wrap-up session. I will share my screen again. Could you please, James, stop your sharing your screen? Yeah.
There we go.
So thank you, James, again, to come here to share your knowledge. If you have any other topics or ideas, you're always welcome. So then from next week, you will find the video of this meetup at our website, continuoustestingmeetup.com. Just come there and check it. And if you have any ideas for your topic, please go there and click on button, submit your talk. Or if you have any colleagues or any friend that want to present here, to share something with us, so just feel free and come to us. We already planned the next meetup and the last meetup in this year. So come here on December 8th. We will have a really interesting topic. I ship CSS as soon as the test pass, and I'm not crazy. So see you there on the 8th of December. So thank you very much. Have a nice evening, nice morning or afternoon, depends on where you are. Bye-bye.
Thank you, everybody.